Hello everyone. Today we are going to see the demonstration of project we implemented called automated attendance system. So automated attendance system basically avoids the hectic task of manually entering the records of each and every students. We just have to take a picture of an attendance sheet and give it as an input to the software. The software will extract the records out of that image and will give the records in an Excel file. Thus it saves a lot of time and error that may occur while entering the records manually. We will detect and extract the printed data and handwritten digits in this project. We have implemented front end as well. Front end is basically a graphical user interface which gives an advantage that one does not have to run the code every single time he or she wants to extract the data out of an image. It is user friendly and anyone with no knowledge of Python can use the software. So one does not have to have knowledge of Python in order to use the software. So now let us see the actual demonstration of the project. Let's see the project demonstration. So now we run the code. We have implemented front end using tkinter library. As I run the code, I get a window having two buttons: login and register. If the user is not registered, then it will throw an error if he tries to log in first without registering. It will throw an error saying user not found and will not give the access to buttons which are assigned functionalities of extracting data. As I hit login button, it says user not found. So we first have to register and then log in. As we are trying to register here now. As I hit submit, it will say registered successfully. Yeah, registered successfully. Now we go for login. As I hit as I hit login button, it will give me two more buttons having names, printed data and handwritten data. If I choose handwritten data, then it will ask me for the image from which I want to extract the data. I have two sample images in the test folder, I guess. Yeah, images. Yes, test image 1 and test image 2. We'll go for test image 1 first, and from here on Rahul will explain the further procedure.
So now I'll try and explain handwritten digit recognition. I've decided to divide the project into two parts. This is the first part of the project, and as you can see, this is the second part of the project. In the first part of the project, we try to create a classifier file. First, I'll let you see the input image. So this is my input file. As you can see, all these numbers have been handwritten, and the objective of this part of the project is to make sure that I use a machine learning algorithm in order to properly detect these numbers. That means a machine learning algorithm should be able to identify, okay, this number is a 0, this number is a 5, the number adjacent to after 5 is 2, and all that and such stuff. So this is the code for the first part. In the first part, we try to, as I said before, we try to create a classifier file. So as you can see here, that is importing and loading the data set. First, I use the MNIST dataset here. Now, what is MNIST dataset? The reason why I use the MNIST dataset is here. MNIST dataset contains around 60,000 of images of numbers, and the numbers are from 0 to 9. So I'll use the MNIST dataset to train my machine learning model. What happens here is in the MNIST dataset, as I said, there are numbers from 0 to 9, and there are total 60,000 images of those numbers. So so if I divide 60 by 10, I'll get around 6,000 numbers. But the thing is, in MNIST dataset, the images are not uniformly distributed. So since they are not uniformly distributed, it can happen that there will be 7,000 zeros, there will be 6,000 ones, and all that, and vice versa. So as you can see, I've also given the count of the number of digits of all the numbers. So you can see we have here 7,877 ones, we have 7,293 sevens, and we have 6,903 zeros. So as you can see, for every number we have around 7,000 of those. For every digit we have 7,000 of those handwritten numbers. So this is a huge data set which can be used to train the model. So that's why we use memory data set here. Now the second question here is, what kind of algorithm should we use? There are two algorithms that are very useful when we have to classify objects or data or things. The two algorithms are KNN, that is K-neighbor nearing, and the second one is SVM, that is support vector machines. Now the reason why we use SVM here can be explained as follows. Let me show you the SVM algorithm first. Yeah, as you can see, this is the support vector algorithm. Now, what happens here is, let me give you an example here. Let us say that we have two numbers in an image, 1 and 2. Now, the machine learning algorithm has to determine which number is 1 and which number is 2. So, what the machine learning algorithm will do is, first it will use the classifier file that I've already told you about. So, it will have 6,000 of 1 or 7,000 of 2 and such case. So what it will do is, first it will learn from this data and it will divide the data into two groups. As you can see here, one group of data is in red and the other group of data is in blue. Now it will take the worst cases of both those groups. As you can see here in the here we have the center line. The center line is called as the center line is denoted by X, but it is called as hyperplane. The objective of this hyperplane is to divide those groups so that no point can be classified as a mistake. No point can be misclassified. That is, one shouldn't be classified as 2 and 2 shouldn't be classified as 1. So as you can see, the middle line is called as a hyperplane, and the two borders around it is called as the support vectors. The reason why it is called as support vectors is because, as you can see, those border lines are drawn in accordance to the worst cases of the groups. That means if I talk about 1 and 2, the worst case of 1 will be considered and the worst case of 2 will be considered in order to draw those vectors. So that makes it obvious that if we have a good case or if we have an easy case of 1 or 2, it can be easily classified. But even if we have a bad case, even that can be classified. So that's how SVM works, and that's why we use SVM. Now, the reason why we don't use KNN is because in KNN we have to tell the algorithm, okay, these are the number of points that I want to consider in my circle or the border that I want to use. So that can be a tricky part, because that's the part that the programmer or the person who's making the algorithm has to decide. So that can be a tricky part. That's why we go for support. That's why we use a support vector algorithm here. So as you can see in the first part of the project, we decide what algorithm we are going to use and why we use MNIST dataset to train a machine learning algorithm, and we use the support vector algorithm. As you can see at the bottom of the code, I've generated the classifier, and the classifier has been saved as a file called as numbers.cls.pickle file. The pickle stands for pickle file. Now in the second part of the project, as you can see, I have used the pickle file again that I had generated in part 1, and I also read the input file again, input image again. This is my input image. And as you remember, the objective of the part of the project is to make sure that I identify all these numbers properly with the help of SVM. So now when I run this file, as you can see, I'm trying to run the file. So yeah, as you can see, all those numbers have been identified properly with the help of SVM. 0 has been identified properly, 5 has been identified, almost all the numbers, not even almost, I guess every number has been identified properly. That means we have a very high accuracy here. Also, you can see that I also save the file as the final with the name of final output JPG in Jupyter. When I go to Jupyter, we can see that the file has been saved as final output JPG here. And when I open the file, I can see that this file has been stored as this file has been stored as a final output file. So this is what the handwritten digit recognition does. It takes the input image and it uses MNIST dataset to train the machine learning algorithm. The machine learning algorithm that we use is called as support vector machines here. We generate the classifier file in the first part of the project. We use the classifier file project to detect the numbers properly in the second part of the project, and then we also store the project automatically. All this can be done within the code itself, and it needs very less human intervention. That's why it's very automatic, and that's why it's called as the automatic attendance system. All this can be done with.
So we again log in now. We want to extract the textual data, printed textual data. So as I hit the login button, I'll get 2 more buttons. Yeah, now we choose printed data button. So as I hit printed data button, it will again ask me for the image from which I want to extract the data. We'll go for test image 2 this time. Yeah, test image 2 this time will go, and from here on Kaivan will explain the further procedure followed in the project. Let's see the further demonstration.
After the extraction of PDF into image, we get this following output. For extraction of individual row from the table, we apply this 5-step process in this Python IDLE program. First, we apply grayscale, threshold and inversion. Then, kernel length allocation is done. Kernel length allocation and individual length of a row and column is applied. Then we apply morphological operations. For addition of separate images, first we add weight parameters. And in the last segment on this part, we first identify the contours and row extraction is done. Post running this module, we get the 5 individual rows extracted from this table into a separate folder. As it is visible from the output, we get this 5 rows which is extracted into this folder, which is mainly useful for extraction of text from this image.
So now we can see the records extracted in an Excel file. Thank you.